Okay, so this is properties of logarithms notes. The central question is, how do you know when to use addition or subtraction to write multiple logs, like example 1? So properties of logs is our main idea today, so make sure you write that in the left-hand column. So I put these properties in here for you. So the product property says that if I have log base b of two things multiplied, I can split that up as log base b of m, so one of the things, plus log base b of the other thing, n. Now the reason why this is because remember, if I think back to when I had x to the third times x to the fifth, well, what we ended up doing was this was 3 plus 5, which gave us x to the 8th. So remember, a log actually represents an answer that is an exponent. So when you multiply, when you have multiplication between the two items, that is when you add the exponents. So that's why we're adding these exponents, because this log base b of m and log base b of n represent one of these exponents, for example. Okay, so that's where that's coming from. I just want to give you the why behind it, but you do need to know these properties. So the quotient property, if you have log base b of something divided by something else, then there's subtraction between them, and the one that's on the bottom has the subtraction sign in front of it. Now this goes back to, because when we had x to the 8th over x to the 5th, we subtracted the exponents to get this. Okay, so the reason why this is, if I take log base b of m, so that would be, let's say that's the top exponent, minus log base b of n, that means that the original problem was dividing those. Okay, so that's where that property comes from. And then the last one is called the power property. So if you have log base b of some number to the n power, this property says that that is multiplied in front. And this comes from, like when we had, I don't know, x to the 5th raised to the 3rd power. Well, remember what that meant is that you multiply the exponents. So we do 3 times 5, and that will give us 15. So what this is saying is that you have some number raised to a power. That is this situation where we multiplied. So you would put that exponent in front of this, because that would be that exponent times this exponent, because log base b of m represents an exponent. So that's where these are coming from. They're basically the reverse of all of the exponent properties that we had. Okay, so let's do example 1 here. So rewrite the expression as multiple logarithms. So that means we want to take it and write it, expand it out as far as we can go. Okay, so we have log base 6 of 2 times x. So that means that we're going to be using this property because we're multiplying two things inside. Okay, so for part A, then we break it up. We say log base 6 of the first thing, 2, and then it'll be plus log base 6 of the second thing that's multiplied, which is x. And then we don't have any division, so we don't need to do that one for this problem, and we don't have an exponent inside of our log, so we don't need to do that one. So part A was just doing the product property. Okay, now let's look at part B. So this is your final answer. That's as far as you can go. Okay, now let's look at part B. So part B has log base 2 of x divided by 3. So we're doing division, so that means it's this property. Okay, so then that means we split it up, and whatever's on the bottom gets the minus sign in front. So we're going to do log base 2 of the top item, which is x, minus log base 2 of the bottom item, which is 3. And there's no exponents inside here, so I don't need to do that last one, so that is your final answer. Okay. All right, let's look at this last one. So part C. So we have multiplication, we have a 3 and an x squared. And it's log. Remember, when there's no base number there, that means that implied base number is 10, but we don't need to put that in our problem. Because if we don't put it, it's implied that it's 10. Okay, so first we're going to use the product property. Okay, because I'm multiplying 3 times x squared. So that would be log of the first thing, 3, and then it's plus for this, log of the second thing, x squared. So this is what I have so far. So I just used that one. There's no division, so I'm not going to use that one. But I am going to use this last one because notice we have this x squared here. And we don't like to have powers inside a log. So what that means is we need to take this and it gets multiplied in front. So then what we have is this, what we had, log of 3 plus, and then that exponent 2 goes multiplied in front, log x. So this is your final answer. So first we use that first product property to break it up because we had a 3 times x squared, so we had to do that first property. And then we had an x squared, so we can't have exponents inside a log. So that power property says we take that exponent and multiply it in front. So I took that 2 and multiplied it in front, and then here's your answer. Okay, so when they want you to rewrite it as multiple logs, it means it wants this right-hand side of these properties. Write it out as far as you can go. Okay. All right. Now they have it expanded, and this is a multiple choice problem, so which of the following is equivalent to this? This is expanded, and we want to make it 1 log. Okay. So let's take this piece by piece. So we have log 9 plus 3 log 2 minus log 3. Okay, now the first thing I notice is that you have a number multiplied in front. So if I go back here, when you have a number multiplied in front, so now we're going from right to left. So from right to left, when you have a number multiplied in front, that means that it goes as the exponent of whatever's inside the log. So if I come here, this 3 then is going to become the exponent on this 2 that is inside the log. So now we have this. This stayed the same. And now this is log 2, and that 3 is now the exponent on the 2. And then everything else is the same. Okay. Well, now I'm going to go ahead and evaluate this. So I have log 9, because notice there's no exponents in your answers here, since it's multiple choice. So then this will be log of 2 to the 3rd, which is 8. Okay, so now I'm just going to take this one piece at a time. So I have addition here. So if you look back here, when you have addition, that means you're going to multiply those two things inside the log. So then we need to go here, and we're going to do log, and this will be 9 times 8 inside that log. And then I still have minus log 3 here. Now I'm doing this in more steps. When you get really good at this, you don't have to show all of these steps, but I'm just showing you each time what I'm doing. Okay, so now we have log of 72 minus log 3. So I just multiplied the 9 times 8. Okay, now we see subtraction. So subtraction means that we are going to have division here, where wherever the minus sign lies, that's the number that's on the bottom. So then if I come here, I'm going to rewrite this. This is now going to be log of 72 over 3, or 72 divided by 3, because the minus is in front of the log 3, so that means the 3 is your denominator. And then you go ahead and simplify that. So 72 divided by 3 then gives you the 24. So it gives you log 24, which is letter D. So this problem actually used all three properties at some point. Okay. Okay, so now we're going to practice that same thing where it's all expanded, but then we're going to rewrite it as a single logarithm. So that means they want us to condense it. So we'll do part A together, and then I'll have you work, try part B and C, and then you can unpause it to check. Okay, so example 3. So part A, rewrite this quickly here. Okay, so I'm just going to take this piece by piece. So this one, I'm going to take this part first. So we see addition, so then that means we're going to use this first one here. Because I see addition, which then means if I'm going backwards here, that means I have to multiply those two things together. So now this is going to be log of x times y squared, and then I still have my minus log z. Okay, so then we go back, we see subtraction. So if I see subtraction, that means wherever the minus sign is in front of, that's my bottom number of whatever this is, whatever the fraction is. So then if I were to do this part, so I still have log of xy squared multiplied together, and since the minus is in front of log z, then that means z is in the denominator. And that's as far as you can go. Okay, so that used two of the properties. All right, so go ahead and pause and try part B and part C, and then turn it back on to check your answers. All right, I'm gonna erase this one here, and then we'll go ahead and do part B. So natural log of 2 plus natural log of 5 minus 2 natural log of x. Okay, so I'm going to take it piece by piece. So I'm going to do these first two together. So it's addition. So remember that means if I'm going from addition to one log, then it's multiplying. So then we're going to do natural log of 2 times 5. And then we still have that minus 2 natural log x. So if I clean this up a little bit, this will be natural log of 10 minus 2 natural log of x. Now we also see that we have a number multiplied in front. So when there's a number multiplied in front, that means that then goes as the exponent on whatever's inside the log. So then that actually means this 2 becomes the exponent on x. So now I have natural log of 10 minus natural log of x to the second power. So that 2 that's multiplied in front, we're trying to condense this and make this one log, so that 2 needs to go on the x, and that's its exponent. And then I do the last step to clean this up a little bit. I see subtraction. So remember, subtraction means that you have division, and wherever the minus sign is in front of, that is your bottom number. So then we would have natural log of 10 over x squared. That would be your final answer. Okay. Then on part C, we have 5 log of x minus 4 log y. Okay, so when you have a number multiplied in front, that's the third property, the power property. That means it becomes the exponent on whatever's inside the log. So then this 5 goes on the x, and this 4 goes on the y. So then we have this log of x to the 5th power minus log of y to the fourth power. Okay, so that was using the power property. And then if we're to finish this up, you see a minus sign between these. So remember, if there's a minus sign, it means that we have division. And wherever the minus sign lies, that number after the minus sign is underneath the, or in the denominator. So we have log x to the fifth over y to the fourth. There's your final answer. So we'll take some practice. You will have to know these properties, though these properties will not be given to you on the test or the quiz. So you do need to know the different properties. Now, the only reason you would need to use the change of base formula is if your calculator doesn't have the log base function. So if you had to evaluate log base c of a, well then in your calculator you would use your regular log button a, whatever that a number is, divided by your regular log button of c, whatever that number is. Now again, you only have to do this if you don't have the log base function on your calculator. Okay, so let's use our calculator to calculate these or evaluate these. So log base 5 of 8. So I'll show you if you have the log base function, what you type in your calculator. And then I'll also show you if your calculator does not have the log base function, how you use this change of base formula to get the same answer that we were getting. Okay, so this is log base 5 of 8. So those of you with the log base, you go to math, log base, whoops, quit out of that, math, log base 5 of 8. And we get 1.29. So part A, 1.29. Now, those of you that don't have the log base function, here's what you're going to type in. You're going to type in for this log of this bigger number 8, and I say bigger number just size-wise. This number may not always be the bigger number, but log of 8 divided by log of the base number 5. So then in your calculator, you would have to have the log button to be able to do this. So you would do log 8, close your parentheses, divided by log 5, close your parentheses. And notice we get the same exact number. So that's only those of you that don't have the log base function, then this is how you have to type it in your calculator. Okay, so go ahead and pause this and try part B, and then unpause when you want to check. Okay, log base 8 of 14. So if you have log base, you hit math, log base, what was it? 814. You get 1.27. And then if you don't have it, then what you type in is log 14 divided by log 8. And you'll get the same answer. So 1.27. Now, again, you only have to do the change of base formula if your calculator doesn't have the log base function, which most all your graphing calculators should. Okay, so try these 3 problems. Number 1, you're taking that and making it a single logarithm. Number 2, you're taking that single and writing it out into multiple logarithms. And then number 3, you're evaluating. So pause, try those 3 problems, and then unpause to check your answers. Okay, so for number 1, we have natural log of 4 plus 3 natural log of x. Okay. So the first one I'm going to do is get rid of this 3 in front. So remember that becomes the exponent on there. So I have natural log of 4 plus natural log of x to the 3rd power. Okay, so that's what we have now. Then we have addition. So addition means you actually multiply these things in one log. So natural log of 4x cubed is your final answer for this problem. Okay, number 2. Now we want to write this into multiple logs. So we have 3x divided by x to the fourth. Okay, so then to break this up, when you have division, you'll do log of the top number minus log of the bottom number, x to the fourth. So whatever's on bottom has a minus sign in front of it. Okay, well, there's also another thing we don't like. We don't like to have this exponent here. So when you're writing as many logs as you can, we have to put that in front. So that means we have log 3 minus, and that 4 exponent is now multiplied in front, and then you have log x. So that's your expanded version. That's as far as you can go. And then number 3, we can evaluate this in our calculator. So log base 12 of 30. Log base 12 of 30. And you get 1.37. Approximately 1.37. Now, if you had to use the change of base formula, you should have typed in your log of 30 divided by log 12. But that's only if you don't have the log base function. Okay, good. Go ahead and do a repetition and then work on the properties of logarithms practice worksheet.